Now let's talk about this problem. Question number 14. You have been given x is equal to 4 with the equation of the directrix to an ellipse whose center is at the origin and its eccentricity is half. So you can just see in the first statement we have been given many things. So you have been given x is equal to 4, right? So x is equal to 4 means we are talking about equation of the directrix, which is nothing but it is a upon e is equal to 4. Can you see that? And also it has been given that eccentricity is half. So you can just have a look at this part. Say e is equal to half we have. That means if you substitute e is equal to half, what we get? We get a, right? So a is what? A is coming out to be 2 then, right? And also you have been given one more very important thing. If p1 comma beta, where beta is greater than 0, is a point on this ellipse, so you have to find the equation of the normal to it at p is equal to 1, right? So this is what we have to find. So that means p1 comma beta, so since beta is known to us, so if it is not known to us, that means we have to substitute in the given equation. So first of all, let's find the equation of the ellipse. So what we know that e square is equal to 1 minus b square upon a square. This is the relation between a, b and e. So that means if we have e here, it is nothing but we have 1 by 4 and this is coming out to be 1 minus b square upon 4, right? So this is how we can write it. So b square is what? Then b square is coming out to be how much? So b square by 4, this is 1 minus 1 by 4, which is 3 by 4, right? And b square is coming out to be 3, right? So b square is 3 we have. Now, if I talk about the equation of the ellipse, my dear students, what we have x square upon a square. A square is what? Yes, we have been given 4 and this is y square upon 3 we have, which is equal to 1. So this is the equation of the ellipse we are talking about. Now what we can do, we can just differentiate it. We can use the concept of calculus here, tangent normal concept. So what we have, we can just take 2x upon 4 plus 2y upon 3 and this is dy upon dx, which is equal to 0 we have, right? So that means this 2 and this 2 is cancelled. So we have been given y by 3 and this is dy upon dx, which is equal to minus x by 4 we have, right? Or we can write it as dy upon dx is equal to, we have minus 3x upon 4y. Got it? So this is how we can write it, isn't it? Now if you see the point here, that is we have that 1 comma beta point, right? So we need to find that point. So how do you find that point? Because this is again fine, I mean slope of the tangent to the ellipse has been found out. We need to find the slope of the normal. So first of all, let me take the slope of the normal. This is nothing but we have the negative reciprocal of dy by dx, which is coming out to be 4y upon 3x, right? So this is what we have. Now one more thing is very important for us because 1 comma beta is there. So 1 comma beta lies on the ellipse. So what we can do, we can take this point, say 1 comma beta lies on the ellipse. So it satisfies the equation of the ellipse. That means we have, 1 upon 4 and this is coming out to be beta square upon 3, which is equal to 1 we have, right? So it is coming out to be beta square is equal to, we have 1 minus 1 by 4, right? And again this is 3 here, so this is coming out to be how much? 3 by 4, or beta is equal to plus minus 3 upon 2. So beta is greater than 0, it has been given, so beta can be written as 3 by 2. So what is the point P we have? So the point P we have as 1 comma 3 by 2, right? Beta is greater than 0, that's why we have taken beta is equal to 3 by 2. Now negative reciprocal of the tangent, slope of the tangent is nothing but we have slope of the normal. So that means if I talk about the slope of the normal here, it is nothing but we have 4 into 3 upon 2 divided by 3 we have, right, into 1, isn't it? So that means this 3 cancel, we have 2 here, so you can write it as 2 here, and in the equation we can just substitute the values now. See, so the equation of the normal will be y minus 3 by 2 and we take the substitute the slope here, that is nothing but we have x minus 1. So this is basically the equation of the normal we are talking, and the options which has been given to us, the second option seems to be the correct one. When you simplify this, we'll get the second one, right? So hopefully this is clear to you. Now friends, let's talk about question number 15, a very interesting problem. You can just have a look at this part. A and B are real numbers such that 2 plus alpha raised to the power 4 is equal to A plus B alpha, where alpha is minus 1 plus iota root 3 by 2. So we can just have a look at this sum and just see it's a problem based on complex roots of unity, that is cube roots of unity we are talking about, right? Now A plus B is equal to what? So basically what we have 2 plus alpha raised to the power 4. So what we can write, we can just write 2 plus omega and raised to the power 4, and this is coming out to be A plus B omega, right? So this 2 plus omega whole square we can write, and this can be written as whole square. This is A plus B omega, right? And this is nothing but we have 4, and this is coming out to be 4 omega, and this is omega square we have, right? And this is whole square, and this is A plus B omega we can write. Can you see that? So that means here we can just have a look at this part, right? So 4 plus 4 omega, yes, this can be written as 4 times 1 plus omega, and this is coming out to be omega square whole square. This is A plus B omega we have, right? Now this is coming out to be minus omega square, which is nothing but we have minus 4 omega square and plus omega square, that is minus 3 omega square, right? And this is whole square we have, which is A plus B omega we can write, isn't it? So this is coming out to, we can just have a look at this part. See, we have 9 here, we have omega 4, that is omega cube into omega, this is omega, this is coming out to be A plus B omega, right? So see, what we have been given B is equal to 9 here, A is equal to 0. So that means A plus B is coming out to be how much? This is coming out to be 9. So second option is the correct one we have. Got it? Now let me go to the next one. It's a very interesting problem based on sequence and series. Let's have a look at this part. You have been given A1, A2, A and B, the given AP, and whose common difference is an integer. And Sn is A1 plus A2 plus An we have. And A1 is given as 1 and we have been given A as 300, right? And N lies between 15 and 50. So this is a very important thing we have. This is the condition which is given here. And we have to find the ordered pair, this. See, the interesting part of this question is that there are few conditions which are given to you. So you have to be very much careful about that part, right? So let's have a look at this part. So you have been given this term. So An is given to you as 300. So this is again a very important thing. A first term is given as 1. So that means we can write it as 300, right? And this is coming out to be A plus, we have N minus 1 times D we have, right? So what is A? Yes, A is 1. So this is coming out to be 299, right? And this is nothing but we have N minus 1 and this is D we have, right? And D is nothing but is coming out to be how much? We have 299 upon N minus 1. Got it? Now here it has been given that common difference is an integer. So that is a very important thing. It is an integer. That means we have to check now, right? It is an integer we have. So that means what? How can it be an integer? What can be the possible values of N can be, right? So that means N minus 1 can be, because 299 can be written as 13 into 23, right? These are the multiplication of these two terms. So it can be plus minus 13, it can be plus minus 23, it can be plus minus 299, right? Or it can be plus minus 1 also. So there are 8 possibilities we have. But again, the condition is given to you. You can just have a look at this. N greater than equal to 15, less than equal to 50. So that means if I just check it out in this way, we have N minus 1 is what? We have first one. See, let me take it as 13 suppose. Isn't it? So 13 means we are talking about N is equal to 14. But we can't take 14 because N lies between 15 and 30. Anything else we can take? Yes, let me take N minus 1 is equal to say 23 suppose. Right? So what we have N is equal to 24. So yes, N belongs to this particular range, that is 15 to 50. So you can take N is equal to 24. So now we can just find it out. SN4 we know, how can we, the formula for SN4. SN4 is somewhat like, you can write it in this way, n minus 4 divided by 2, right? And this is nothing but twice A1, and this is n minus 5A into the common difference, right? This is what we have. Now, yes, if we just talk about this part, we can just substitute the values. Now, what is D? So yes, D is nothing but, we have 299 divided by, we have 20, this is 23. So just have a look at this part. This is 23 we have, right? So n minus 1 is 23. So 23 we have. So that means we can just cancel the terms. So what is the value of D we have? We have 13 here, right? So this D is 13, isn't it? So if D is 13, we can just substitute the value of D 13 here. A1 is known to us, N is known to us, right? Similarly, we can just get AN minus 4, which is nothing but we have A plus N minus 4. This is minus 1 into D we have, right? We can just substitute the values here again. And once you substitute the values, we get the option 3, right? So this is a very simple calculation. Substituting will give you the option 3rd. Hopefully this is clear to you.